everyone. It's a pleasure to be here at Next with all of you. I'm Prajakta. I'm a product manager in cloud networking.
And thanks for being here. My name is Mike Columbus. I manage a specialist team of networking professionals that help customers like yourselves on their journey to Google Cloud.
So what does it really take to build and manage services in today's world? The world is hybrid. The world is multi-cloud. Customers have hybrid and multi-cloud deployments because they want higher availability. They want to mix and match the best-of-breed solutions from each of the clouds, or because they cannot move all of their services to cloud. Now, there's no doubt that hybrid and multi-cloud deployments are here to stay. But one of the questions we hear all the time from customers is how can we go and manage these deployments seamlessly without all of the toil? One of the big trends that we see is the move from monoliths to microservices, and they're moving to them for agility and then also for manageability. But imagine you had a monolith, you took it, you chopped it up into 120 microservices. How are you going to deploy, secure, connect, manage these microservices? What you really need is a way to create new services uniformly. You also need services management infrastructure, which you obviously don't want to create, build, or manage. And you need security, resiliency, and observability for your services. And that is where Service Mesh comes in. Now, Service Mesh is a very powerful abstraction that's becoming increasingly popular to deliver microservices and also for multi-cloud applications. So think a few years back, like what exactly is Service Mesh? Think of boxes, appliances a few years back. You had all of these complex network appliances. What did you do to them? There came software-defined networking, and you took this complex box, you disaggregated it, you created a very simple forwarding plane, and you moved all of the complexity up to the control plane. And then these simple data planes were controlled by that control plane. Think of Service Mesh as exactly SDN for services. Now, what are you doing here? You're taking a complex application, you're removing all of the networking code from it, you're putting a load of it as a sidecar proxy, and then you need something to go manage all of these sidecar proxies. And that is where the control plane of the Service Mesh comes into the picture. So let's take a closer look at the Service Mesh. What is a mesh? Essentially, a mesh abstracts away the network from your application. So your individual services or the apps you write don't necessarily have to be aware of the network. They only know about their local sidecar proxy. Now, each proxy obviously has to be configured and managed. And so that's where the Service Mesh control plane comes in. It takes all of these distributed proxies and configures them into something larger. And then you get visibility, you get resiliency, you get traffic control, security, and observability. So that is actually the value add of your Service Mesh. Think of the data plane. We talked about a sidecar proxy. One of the most popular sidecar proxies is Envoy. It was built at Lyft. It is a very high-performance proxy. It has eventually consistent service discovery. And the reason we like is it's extensible, and it has a protocol called XDS v2, which it uses between the control plane and the proxy. And so you could use any other proxy that supports this XDS protocol, and therefore you can use Envoy that Istio provides, you can use Envoy that is your own, or you could use another proxy that is compliant with this XDS v2 protocol. So it's fairly, it doesn't lock you into any specific proxy or even any specific control plane. So the biggest benefit of Service Mesh is that it decouples development from operations. And so as a developer, you don't need to worry about writing and maintaining policies and the networking code inside your application at all. One of the really nice things about Service Mesh is it doesn't make any assumptions. Now, it doesn't make assumptions whether your service is in cloud, on-prem. It doesn't make assumptions about whether your service is a VM-based service, a container-based service. So it assumes things are heterogeneous. It assumes they are spread out. And that is what it affords you, in that it gives you this unifying abstraction to create services and obviously manage them at scale. So one of the most popular service mesh technologies, which is an open source, is Istio. What is Istio? It's essentially giving you three main things. One is advanced networking capabilities and routing capabilities, but without you having to write that code. Enhanced security, And it is also giving you a lot of observability into what is happening as your services communicate with each other. Let's take a closer look at Istio. Now, look at the data plane. That is where you have your service. Sitting next to it is a sidecar proxy. And then on the top is the control plane. So it has three main pieces: Pilot, Mixer, and then there's the Istio security bit. Pilot's going to give Envoys the configuration. It's going to do the load balancing. And then it's also going to do service discovery. What you have on the security side is things such as mutual TLS between your services. And then observability lets you map out all of your services along with the traffic flow and then other things that are happening as your services communicate with each other. Now, one of the other things that you would also need for your service mesh is you need something that guards your entry point. And that is your Istio Gateway or your ingress. And now this is where you would essentially deploy something like a global load balancer in front. The reason is that you need the DDoS defense. You would put your Istio Gateway on instances behind, and then that becomes your entry point to the mesh. So if you think of it, you've taken all of the traffic routing, all of the customization, all of the programmability, right to the edge of your service mesh with this one. One of the key pieces of Istio is Pilot. This is the one that goes and manages and configures all of the Envoy proxies. It is the one that knows about all of the other Envoy instances. It's the one that provides service discovery, and it also delivers advanced traffic control. Now, our customers love service mesh, but they always say, we don't want to go and build these control planes. We don't want to go manage Pilot. And so what did we do? If you were there in the keynote this morning, we launched Traffic Director. So you're one of the first few people to hear about it after that launch. Our new GCP-managed service for the service mesh. And what it really does is it helps you power up service meshes of all types, of all sizes. You get global load balancing, which is huge, and we'll talk about it a little bit more. You get centralized health checking. So there is somebody that's offloading your proxies from health checking every other application instance there is in your network. You also get traffic-driven autoscaling. So as your traffic grows, your services scale up and down. And then you get traffic control capabilities like canaries and so on that we'll talk about a little bit more. One of the nice things is Traffic Director is GCP-managed, which means you get a production-grade SLA at GA. And so if something happens, you can call our support. You don't have to worry about it yourself. So if you look at this, you see Traffic Director in the control plane. It's managing the sidecar proxies. One of the nice things about Traffic Director is it works out of the box for VMs and containers. So if you look at the service here, imagine that your front-end service is essentially self-managed Docker. Your shopping cart service is deployed in VMs because you possibly had that service from before. And then your payment service could be, again, in VMs, or it could be a GKE service. And so what this means is you have a unified way to do traffic management for any type of service without having to have a separate implementation or a solution for each one of these types. Now, a lot of you here are likely our global load balancing customers. And one of the questions we would always get is, when are you bringing global load balancing to microservices that are internal, not external facing? And that is where Traffic Director is going to bring global load balancing to your internal microservices and to the service mesh. And to take a closer look at it, I'd like to invite Mike to give you a deep dive into the global load balancing aspect.
Thanks, Prajakta. Good job. All right. So in the next section, I'm going to talk about global load balancing with Traffic Director and also have the pleasure of doing a few live demos in front of my new friends here. So no pressure there. And then finally, we'll take a deeper look at what happened under the covers when I ran these demos. We're going to take a few different views into the environment, so it should be fun. But before we get to that, I think it's really important to understand the data model that Traffic Director uses. I'm sure a lot of folks in the audience have deployed a load balancer on Google Cloud Platform. This data model should look similar, right? So the first thing that you need is a global forwarding rule. This consists of an IP, a port, and a protocol. And what's a little bit different about this global forwarding rule is that the IP only has significance to the services when they try to talk to other services inside of the mesh. The IP can really be anything, right? And I'll get into a little bit more about how that works later. So think of it this way. For every service inside the mesh that needs a unique VIP, you're going to need a global forwarding rule for that service. Global forwarding rules point to target HTTP proxies. A good way to think about this is these are the actual service proxies inside of your mesh, right? So this is really powerful. These proxies are the ones that are getting traffic redirected to it and creating the policy that's distributed throughout the mesh. So within a target HTTP proxy, think of this is really just a config pointer. In this target HTTP proxy, you'll configure a URL map. The URL map has been enhanced to allow for things like rule matches and rule actions, right? So really powerful things that provide granular traffic routing policies on top of just looking at the host or URL path as part of the L7 mesh. The URL map points to your backend service. This backend service is global, and this is where you're going to configure things like health checking, along with some enhancements that are part of this launch, which are traffic policies that Projecta will cover later. In each backend service, you can configure your backends. These can consist of managed instance groups for VMs or network endpoint groups for containers or GKE. So what's really cool about the solution is you don't have to be running containers or Kubernetes to take advantage of this, as long as you can install a service proxy on your VM or on your pod or on your container. You can leverage a lot of the power that comes from this platform. All right, so here we can see a high-level view of the Traffic Director service mesh. We've shown this a few times. It's also what maps to our demo, so it's pretty significant here. So what we have here is a web service that's behind our global load balancer. So we have two back-end managed instance groups. They happen to be running Docker containers, but they're managed instance groups of VMs deployed in US Central and Asia Southeast. So depending on where that client hits our edge, our front-end network is going to route them to the optimal healthy back-end with available capacity. From there, we have a cart service and a payment service that is mirrored in each region. So what's really cool about Traffic Director is we have a global view of available service endpoints, and our infrastructure keeps a map of what is the RTT between these endpoints. And the default policy is that we're always going to route traffic to the healthiest endpoint with available serving capacity. So we'll start with the closest zone and fail over to regions and redirect traffic accordingly. Now, I want to take a minute just to contrast this architecture with how you might do this in a traditional three-tier app, right? You're going to have some sort of middle-edge proxy load balancer, and you're going to configure it on a hop-by-hop basis. With Traffic Director, think of it as embedding a client-side load balancer at every service, and the policy is also embedded as a sidecar directly on that service. So once traffic gets directed to the proxy makes a really intelligent routing decision for the next endpoint, and that's a direct communication without having to funnel traffic through something else to make a load balancing decision. So here we can see the view of Maya in California. I guess I'm Maya today, but I'll be running the demo here from the Moscone Center. So under normal circumstances, I'm going to hit the global load balancer. That's going to direct me to the web front end. The web front end is going to call the cart service, and then that's going to call the payment service. So we're going to buy a lot of things today. But under normal circumstances, default policy, it's going to route me as such through US Central. For Shen in Singapore, and I have a client that's going to emulate a Singapore client, I'm going to be routed through the Asia Southeast 1 web service, and then throughout the mesh in that region. So what we're also going to do, and this animation shows this, is that we're going to fail the US Central 1 cart service and observe the behavior. So because Traffic Director has global view and tries to route things optimally, once the US Central 1 service fails, you're going to see that we get almost instantaneously directed to the healthy capacity in Asia Southeast 1. And then we'll fail the server back, and we'll take a look at this. So if we can switch to the podium. Very good. So here you can see we have a Traffic Director demo project. This is where the environment's contained. And I want to show a few things. So I can prove to you that this is a real environment. So the first thing I want to look at is our instance groups. So we have a few. The first you can see is that we have 2 web backends. These are backends behind the global load balancer. This is our web service, and we have 2 managed instance groups of 1 instance. I don't recommend doing a managed instance group of 1 instance, but I guess it allows us to be fairly frugal for this demo environment. Next, I'll call out the cart service, which is this managed instance group here. So that's running as a VM managed instance group with Envoy installed on each managed instance group VM. Finally, we have our payment service. This is running on Container Engine, or GKE. So we have a deployment, which is our V1, and later in this presentation, we'll show a traffic splitting canary style release, but that's running as on GKE. And we can jump over into our Kubernetes engine, and we can take a look at these workloads or these deployments. Now, these manifests have an annotation on them that says use network endpoint group. So if you're not familiar with, I know I described this a little bit earlier, but if you're not familiar with what network endpoint groups are, think of it as a port and IP pair that allows us to directly target the container rather than the node. And why this is important is if you're familiar with how Kubernetes works, there's something called the kube proxy that's almost like a second hop load balancer that would then select a pod behind that service. This allows us to directly target the pods themselves. And there's a controller that gets spun up, so as pods are scaled up or down, or they go away, or new services are attached, that is going to program the endpoint awareness for a traffic director to know where to send traffic. So a little bit more on that later. And finally, before we jump in and start buying things, we have our network services. We have traffic director in the UI. So here, you can see that we have our cart and our payment backend services, and they each, thank God, they're healthy, but they each have a backend in Asia and US Central, right? So that's the environment. So what I'll do first is, this is a local client. This is me, Mike, in California. And you can see that this front end is served by US Central 1, right? So the global load balancer directed us to the web service in US Central 1, which is good. The other thing you might note is that this domain is secured. Just a little side note, this is using a Google Cloud Managed Cert on our global load balancer. It's also using identity-aware proxy. So if you're trying to get to this site, while I trust everyone here, I can't have you stopping the services. So we're just going to leave it at that. So normal connection here. I'm on the web front end. Let's say we want to buy a $300 popsicle. Kind of crazy. We'll add this to our cart. And you can see now this changed to say this is the cart service in US Central. And then we'll confirm the purchase, and we can enter our shipping information. But it's interesting. I don't see any shipping price being calculated here. Wouldn't it be cool if we had that? So that's a little bit of a tease to our V2 of payments. The next view we'll take, let's buy something as Shen in Singapore. So you can see that Shen was directed. I can refresh this so you don't think I'm so. Shen was directed to Asia Southeast region, being a Singapore client. We can get some green slip-ons, and we're directed to the cart service in Asia Southeast 1, and as you might guess, also the payment service in Asia Southeast 1. But what would happen if we failed a service? So what I'm going to do is stop the cart service in US Central 1. So this is not actually like turning down the VM. It's a managed instance group of 1, but we're basically telling the service to now return 500 errors that are going to fail the health check. So now let's see what happens. So let's go back to our, this is me connecting locally. So we'll go to td.gcpnetwork.com. All right, so we're still going to the web front end. This is, again, the global load balancer directing us to the web. Let's buy a clock, and we'll add it to our cart. And you'll notice this is now served by Asia Southeast. So traffic director had no local capacity. It's a managed instance group of 1. If it had something in another zone, it would have used that. But we want to make this more dramatic and fail across region. So we did that. And when we confirm the purchase, it stays in Asia because the payment service is the closest next hop or endpoint for the cart service. So the final thing we'll do here is let's start our cart service back up. This will now allow the cart service to pass the health check, and hopefully, we see everything stick in US Central. So let's buy something else. Anyone have any preferences? Goldfish Bowl? What was it? Radio? I heard radio first. Where's the radio? Oh yeah, it's a bargain at $300. All right, we'll add this to our cart. And the card I brushed by it, but it was US Central, and we stuck on the US Central for the payment service. So if we can switch back to the slides, I just want to cover what happened there. Oh, cool. So endpoint awareness. How does Traffic Director and associated these service proxies know where to go? The way this works for VMs is we have something called Backend Manager. Backend Manager is informing Traffic Director of endpoint awareness, and then that's getting sent to the relevant service proxies, so they know where everything lives, right? I described this a little bit for Kubernetes and GKE. The network endpoint group controller is talking to Traffic Director as an annotation as part of the deployment manifest, and that's how we get endpoint awareness, and we know where the pods are. So what happened when something failed? When I failed the service, the US Central 1 cart service? We're health checking our endpoints as a service, right? Which is very powerful. And then once the shopping cart service went down, again, Traffic Director removed within the service mesh that path, the shopping cart endpoint for US Central for that path, right? Because we're kind of creating this like L7 overlay network here, which is really cool. So from the data plane, what happened? Again, this is client-side decision, so I'm going to show this from the context of I came in from the global load balancer, terminated on the web service in US Central 1, and via the control plane, we know that that endpoint, the healthiest endpoint, the cart service in US Central 1 was unhealthy. So we're going to look at this from the perspective of the web service. So the way this works, we have our VM here, we have our proxy installed, and that's got a persistent connection to Traffic Director. And the proxy is listening on port 15,001 on the local host, and then the web service is bound on port 80 for the actual IP address of the VM. So the web service wants to talk to the cart service. Doesn't know that any service is down, it just has a VIP. This is, again, the global forwarding rule. So the web service requests the cart service, which is this VIP that I configured. And then there's IP tables rules that configures netfilter to say anything, either everything that goes outbound or specific to the VIPs in my service gets redirected as part of the output chain to the service proxy. And again, the service proxy has a configuration, it intercepts the request, and now it can apply the policy that was configured as part of Traffic Director, which targets the endpoint, right? So it knows all the health, it's targeting the healthiest endpoint, which actually sends that traffic over our global VPC to Asia Southeast 1 endpoint. So I'll hand it back to Prajakta.
Thank you, Mike. So now
I was wondering if I was going to get...
So now a quick warning. We are going to take you through a whirlwind of different features. We obviously won't have enough time to spend on each of them, but we wanted you to know about them, and then feel free to get hold of us after the talk. So one of the most interesting features that Traffic Director provides is traffic control. If many of you have used Envoy, you've already used these features. So let's take a quick look. The biggest thing about, before you had to actually go architect all of these traffic control capabilities into either your application or some system. Here you get all of that without doing anything to your application. So if you think of how you configure this, think that there are two buckets. One is the routing rules, and one is the traffic policies. Routing rules look at the client traffic that's coming in, and then they figure out where to send it and what to do with it. The traffic policies are more about your service that's being accessed or being connected to. And so what does that service want? That's what you express through traffic policy. So let's go a little bit deeper into the routing rules. Again, reminding you about the data model that Mike showed, which is you have the URL map, that's where your routing rules reside, and then you have this notion of a backend service in GCP, and that's where your traffic policies reside, because they go and apply to your backend service. So what kind of things would you want to do? One of the things that you'd want to do is essentially imagine you have a version A running of your service, and you decided to roll out 2.0 in staging, and you want to actually split traffic because you want to see how the other new version is doing. That's what you can seamlessly do with Traffic Director and the Envoy with what we call traffic splitting. So you simply put weights like you see here, and it'll split the traffic. Another interesting thing you could do is traffic steering. So imagine that in here, you're looking at certain characteristics of your incoming traffic and saying, if the user agent is Android, send it to the backend service that's actually dealing with Android stuff. And if the user agent is iPhone, send it to the backend instances in the service that's dealing with the iPhone stuff. So, and you can do very rich matches. You can also take a bunch of actions, traffic splitting, redirects. You can do URL rewrites, and then several other things as well. Another very interesting thing is fault injection. So as you write out your service, you do want to test the resiliency of your service, and you want to test it against things like delays, aborts, and so on. And so as a part of the fault injection, what happens here is that the client, when it sends a request to the backend service, there's a delay that can be introduced by the traffic director, say on a percentage of your requests that are getting sent to the backend service. And you can also have certain percentage of your requests going there to be aborted. So in this way, you can actually test the resiliency of your app without really building out any of this infrastructure yourself. This is one of my personal favorite features, which is mirroring. So what you can do here is imagine you have your main app. You can create a shadow app, and then as the real traffic comes to your main app, you can shadow all of that traffic to your shadow app. So, and then the shadow app treats this as fire and forget, which means it gets the response, but it's not going to respond back to it. So it's a very nice way to actually go and test out a bunch of things, such as binaries with production traffic. Or you can debug errors that are happening in production using the shadow debug service. So this is, I really love this feature personally. Now let's come to the second part of it, and there are actually several other features that I didn't cover in the routing rules. But coming to traffic policies, now this is the backend service telling the client, here is how I'd like you to behave, or here is how the traffic should be load balanced across my instances. And so it's from the perspective of a backend service. So each of these policies are obviously specified per backend service. Now let's take an example of one such policy, which is load balancing. So Mike showed you the global load balancing. So initially, he showed the global load balancing, which Traffic Director and our global systems use to figure out which is the zone or the region to send your traffic to. Now, once it lands there, you will have multiple instances there. And so that's when the second tier of your load balancing kicks in. And then it figures out which is the best or the optimal instance to use for your traffic. So you can see 1 and 2, and that's what it is referring to. In the second stage, essentially, you have several different LB algorithms that you can turn on. So things like round robin, least request, ring hash, random, and several others as well. And you can turn on session affinity if that's important to your app. So circuit breakers. How many of you here are familiar with circuit breaking? I think it is a topic we could all talk about for an entire day. But my aha moment about circuit breaking came when I was talking to Georgie, who's a distinguished engineer at Walmart. And he said there are several circuit breaking solutions that exist. But one of the really nice things about Envoy and Traffic Director and this solution is that it's from the perspective of a backend service. So the backend service will say, I can accept a max of 5 connections from your client. And so when the client tries to send more than that, the proxy on the client just throttles itself. So it's like back pressure to the client, but it's from the perspective of a backend service. And this part was what was missing in several of the other solutions that existed. So you had to guess what the backend service wanted from a client's perspective. So this is the thing that is actually huge about circuit breaking. You can also do things like outlier detection, and then you can eject out the instances that actually don't conform to whatever policy it is that you want for your backend service. So with that, I wanted to invite Mike again to give you, we just picked one of the features, which is traffic splitting. It is one of our very popular features, and give you a closer look at it.
All right. Thanks, Prajakta. So we get to buy more things. So as part of this demo, we weren't calculating shipping costs before, and we wanted to deploy a version 2 of our payments that does charge for shipping. So if we can switch back to the podium. Oh, all right, thanks. So while Prajakta was speaking, I did a few things, and I want to talk through what I did. So I am in our Cloud Shell code editor, which is super helpful, and I have a few shell scripts that I ran. The first was actually creating the deployment for the version 2 of the payment service. So I just deployed that, and that's running in GKE. The next thing I did was I added the, let me make this a little smaller. I created the backend service for our new delivery v2 version of our deployment. I created a health check for it, and I specified the flag that made it global. The next thing I did was I grabbed the network endpoint group name for each cluster. Remember, it was US Central and Asia Southeast 1. And I added that as a backend to the backend service I just created. So that was creating kind of the traffic director constructs. And then the final thing I did was update the URL map to split the traffic 50-50 across the two backend services. And what that did was actually deploy this YAML file, which I called canary. So I have a really simple path matcher, and it basically takes the default service and splits it. So you can see I have weighted backend services, and I give a weight of 50 or 50% to the backend service. That this was the v1 version, and this is the version 2. And I might as well show it. And then in Kubernetes engine, you can see if I go into the workloads, each cluster now has the non-delivery version and then the delivery version of v2. So let's buy something. Let's see what we want to buy now. Let's buy a surfboard. It's almost summer. So what I'll do is now when I add this to the cart, again, we're served by US Central Cart. And you can see now I have delivery charge, right? And this is going to be fairly variable. If I refresh this page a few times, you can see it's about half. Well, as you'd expect, it's about half the time we have the shipping cost. So basically what's happening is the client-side proxy, when the cart service talks to the payment service, half the time it's choosing the delivery deployment, half the time it isn't, and I could weight this accordingly. So just one example of kind of how this works, but pretty powerful. And you might say, well, I haven't put in my my address. How does it know the delivery cost? It's a demo. Maybe that'll be free, right? So thank you. I'll hand it back over to Prajakta.
Can we get the slides?
Yep.
So we spoke about Traffic Director, and we spoke about the sidecar Envoy. We actually have another interesting product called L7 ILB, and I'll talk a little bit more about it. If you think of a lot of you may be using load balancers, and what you're saying is, just give me a simple L7 load balancer that brings in all of the capabilities of Envoy, but I don't want to deal with Traffic Director, and I don't want to deal with Envoy. And because all you care about is essentially a load balancer that's for your internal services that brings in all of these capabilities. And that is what L7 ILB gives you. So think of you've got a front end, and then you've got your shopping cart, and you've got your payments, and you simply put the L7 ILB like just like any middle proxy load balancer, and then you load balance your instances behind. You're essentially not injecting any proxies on your backend instances. The other side of it is, there's another set of you who have your existing deployments, and you want to bring in all of this service mesh and all of these modern paradigms into your existing brownfield. And that is the other use case of L7 ILB. So it helps you bring service mesh to your brownfield without disruption. So let's take a look. Imagine that you've got two services, the front end and the shopping cart. You were able to put in the Envoy proxies. You configured Traffic Director for it. Now, you have this really ancient payment service, and there is no way you can go and inject a proxy in there. So what do? But you do want to bring in all the modernization and the capabilities that you would get with Envoy. And so what you do in there is essentially you bring in the L7 ILB, because it lets you have all of the capabilities, but without having to go and inject anything in your backend instances. So it's a really good way to start migrating your services towards these modern paradigms. And this is what it looks like under the hood. So what we did for you is we abstracted out Traffic Director, and we abstracted out the pool of the managed middle proxy pool of envoys. And it looks like any other internal load balancer to you, and you simply configure it that way. So it's as simple as what you saw in the previous slide, but then this is what is under the hood. So we do believe this is a very good way for you to get started with the service mesh, especially in your brownfield deployments, or if you're just looking for that next level of load balancing compared to what you have today. So we spoke about a bunch of features, but honestly, that's just the start. We have several exciting features on the roadmap. Some of these we just started working on. Some of these will come sometime this year or next. But one of the first important things we will do an integration with is all of the security features that you get with Istio, which is things like MTLS, RBAC, and so on. The second big integration we will do is with a number of observability solutions, and we will have more than one. So you can, even today, you can actually go and integrate your own, like if you're using, for instance, Apache Skywalking or any of the other tools, you can go integrate those as well. The third important thing is that we always get asked. So Traffic Director is amazing for services that are in GCP. What do we do with our services that are sitting on-prem? And so that is where we do want to support hybrid and multi-cloud with Traffic Director. So your instances stay wherever they are today, but then you use Traffic Director to go and manage them. Then the fourth thing is a lot of you use Istio. And so if you're using Pilot, Traffic Director is a very good fit for a fully managed service. So which means we have to support Istio API, so you can actually take the Pilot and swap it out with Traffic Director. So that is the whole integration story into Istio and Anthos that you will hear more about in the coming year. One of the most interesting and areas of innovation is federation. This is probably the part where we've just started thinking. But there are other service mesh control planes out there. Some are legacy. Some are totally different implementations. But there needs to be a way to federate these. And you will hear us talking a lot more about federation in the coming months or coming year. So hybrid, I pointed out, this is what it looks like. You've got Traffic Director. You've got your instances on-prem. And then you've got the same Traffic Director managing instances that are in GCP. So that's a hybrid story. This is what the Istio and Anthos integration looks like. So you can see that there's a layer of Istio APIs that you can use for configuration. And obviously, that should work whether your instances are in GCP or on-prem. And then the key benefit of this is you will get global load balancing for all of your services. You will get a highly managed control plane, which you don't have to worry about managing, even for your services on-prem. And one of the nice things, again, is that we use the XDS v2 APIs for communicating between the control plane and the data plane. What that means is you're not locked into Traffic Director. So you can swap it out back for Pilot or another implementation as long as it uses the open XDS v2 APIs. So this is what federation could look like. This is probably a place we'll innovate with the community as well. And so you will hear more about it in terms of Istio and several other communities that we are a part of. But what is the need for federation? Like, what is driving the need for us to go look at this? First thing is, there are a lot of implementations where you want a flat mesh. So you want seamless melding of what's on-prem and in GCP. The second one is, if you have Traffic Director control things that are on-prem, you should assume that the connectivity between on-prem and GCP will fail. And so you need a backup control plane. So there's a whole aspect of resiliency there. The third one is sometimes you want to have very controlled collaboration because entity A might be a totally different setup from what's in GCP. And you want to federate state, like things like config, identity, but in a very controlled manner. And so you need proper primitives, interfaces, and abstractions to make that happen. And then the last one is people are going to have a variety of control planes. And as we introduce Traffic Director, for instance, we don't expect people to throw away all of their control planes at once, because they're going to test it out, and then they're slowly going to introduce it into a variety of their deployments. And so we do assume that the world will have multiple the service mesh control planes, and we have to figure out a way to operate in that environment and then help you move your services over to Traffic Director, or if you choose to keep the other ones, that too. So what do we have overall in GCP? Like, we spoke about a bunch of things today, gave you a whirlwind tour of the Traffic Director and L7 ILB capabilities. So let's again go back to your starting point. If you are a cloud load balancing users, you can think of Traffic Director as bringing in Envoy. And this could be in the form of just a managed middle proxy. So you use it like any other load balancer. So it's just like an L7 ILB that's there for your services, but with the primitives and the modern traffic control capabilities that you get with Envoy and with Istio. Then if you're one step ahead in your modernization phase, or if you have new apps that you want to bring in there, that's when you would use Traffic Director with, just like with a traditional service mesh, where you've got the Envoy as a sidecar proxy. And then the main thing is that in both of these cases, you don't really have to worry about managing the control plane, because you actually want to worry about your apps and your business. The last thing any of you here want to do is go manage these control planes. So that is what it's letting you do in here. One of the nice things is that this works out of the box for Kubernetes, like I mentioned before, self-managed Kubernetes, GKE, Docker, VMs, because one of the things I hear very frequently is service mesh is for containers. Actually, that is not true at all. Because if you took a monolith and you chopped it up, because if you containerize a monolith, you're not going to get any benefits. So if you're taking a monolith and chopping it up, the first thing you're actually going to need is services management before you even containerize. So one of the misconceptions that we want to remove and also make it true with Traffic Director is that service mesh is for VM-based services and for containers. It is for greenfield, and it is for brownfield. It is for enterprises, cloud natives. It is an abstraction that should work across the board. And then, of course, we have gRPC is another project in which Google is involved. That is an excellent interface if you have apps that support gRPC. And then most of our testing for all of Traffic Director has been with Envoy. We really like the Envoy proxy because we believe it delivers almost like a universal data plane. But any other proxy that supports XDS can be brought in. There is nothing that locks you in either into Traffic Director or into Envoy. You can bring your own Envoy as well. The second part of it is, so you're coming now from the service mesh or a service management angle. And so that is where, if you see here, this is like when you think about Anthos, or you think about GKE on-prem, or you think about Traffic Director or Istio, what it's really helping you do is to deliver hybrid multi-cloud services at scale seamlessly without toil. And so this is a portfolio of products that's going to help you do that. Imagine that you added a few more to it. So and as we integrate with Anthos and Istio, like, it'll be much more easier for you to migrate from any of the things you're using currently to Traffic Director or L7 ILB. Again, in here, there's nothing that necessitates Kubernetes, but on-prem, we have several customers who have brought in GKE on-prem. And then in Google Cloud, the fastest way to containers is using the Google Kubernetes engine. So this is the last part. There is a customer we have called Mercari. So this example is actually inspired by them. This is how they are thinking of a blueprint to go and modernize at their pace without toil. So in their case, they had essentially a monolith on-prem. And what they went to is something like this. And you can notice that there's no monolith on-prem. So how did they do it? What they did is, and you can just follow the numbers, what they did first is they essentially did nothing to the monolith. They came to cloud, and the monolith, of course, was on-prem. They came to cloud. They put a Google global load balancer. This was for DDoS defense. This was for TLS termination, and so on. And they put API gateway instances behind the global load balancer. So now your traffic comes in. It seamlessly gets routed through the API gateway to on-prem. So that was the first set of things that they did. Then they started chopping away at the monolith. What they did is they took a chunk of the monolith, and then they created service A. So you see the number 2 there. They had a gRPC interface for it. Once they did that, they actually chopped out service B. One of the things you'll notice is every time they chopped out anything from the monolith, they created it as a containerized service. So it was created as a containerized service in cloud instead of doing it on-prem. Once they're done now service B, there were certain services that could not be moved to cloud. So what do you do there? So they chunked out the service C. You can see the number 4 there. And then they put it on-prem, but then they used GKE on-prem to manage it, because they were using GKE, which is our Google Kubernetes engine in Google Cloud. And so GKE on-prem gives you the same primitives, but to manage things on-prem. And you must have heard a lot of it in talks in this conference as well. So now they have GKE on-prem managing Service C. They said, now we are ready to try out the Service Mesh and some of the newer capabilities of the modern paradigms. And so they now put Envoy proxy on Service B and Service C. This is so that the services could communicate. But now you need a control plane, because something has to go manage those proxies, and something has to make sure that they get configuration and so on and so forth. So they first brought in Istio, because Traffic Director wasn't available there. And then Istio controlled Service B, and Istio on-prem controlled Service C. Now after this, what will happen is, now that Traffic Director is available, the pilot from Istio can be replaced with Traffic Director, which is what will happen. And then eventually, when we support hybrid, you can see the arrow 6, which will be able to go control those services with the proxies on-prem. And by this point of time, because you've chopped up all of these services from your monolith, you can see that you've totally taken away the monolith itself. So if you see here that it's not that people just bring in all of these technologies one shot. They have a strategy, and they bring it in the way that makes sense for them. This is just one strategy. There's another talk we're doing tomorrow which describes several of these strategies. But this is a good way to bring in Service Mesh. And of course, there's the brownfield strategy where you could totally use L7 ILB as your starting point. So our hope was that, I know we gave you a whirlwind tour of Traffic Director, L7 ILB, how it fits into the whole ecosystem. But our hope is that using these GCP services and also open source services, you can manage your services seamlessly and modernize from your starting point at your pace and without toil. Thank you. Oh, yeah. And one last thing, we have a survey. We'd really appreciate it if you filled it. We also have an online Dory. So Dory is where you can post your questions, and then Mike and I will respond to them and post them back online. So thank you for being here for the talk. Thanks.